Good morning to all of you. In previous session we were discussing about convolution sum, and we have seen one of the method how to identify convolution by using graphical method, right? So basically convolution is used to identify the response or behavior of the given discrete time linear time invariant system. To analyze the DTLTI system we can use convolution. So in today's session we'll be discussing two methods, that is tabular method and the matrix method for identifying convolution. Okay. Most of the time in most of the books this matrix method is given as the tabular method. Okay, but these two methods are different. Okay, tabular is separate method and matrix is another method. Okay. So again we will try to solve one example here as I solved it in the previous session. We have to identify the response of the system. Okay, the given impulse response, that is h of n, is this 1 to 1 minus 1, and the input signal is x of n is equals to 1 comma 2 comma 1 by 2 comma 1. Okay, so for this given input signal and the given impulse response you have to identify the response of the system. Okay, you have to identify response, that is nothing but y of n of the system. Okay, and this can be identified by using the convolution summation formula, that is summation k is equals to minus infinity to infinity x of k into h of n minus k. Okay, so it is not necessary that you will be provided with only sequences, right? Here h of n and x of n are given in the sequence form, but it may possible you will be provided with these sequences may be provided in the functional form as well, right? So if these sequences are provided in the functional form, then you need to compute or represent it in the sequence form by substituting various values of n in the given sequence, right? So this y of n we have to identify, okay, by using this convolution formula, right? So as we have seen in the previous session, initially we need to identify the total number of samples in the given or in the response sequence. Okay, so how the total number of samples will be identified in the y of n? So divided total number of samples in y of n will be equal to number of samples in x of n plus number of samples in h of n minus 1. Okay, so there are 4 number of samples in x of n. Okay, so there are 4 samples. Similarly 4 samples in h of n. Okay, minus 1, so there will be total 7 samples, okay, in y of n. Okay, similarly you can identify the start time of y of n, okay, from which time small n y of n will start, right? So here what you are doing, you will be adding what, the lower limit of h of n and lower limit of x of n. Okay, so after adding these two values you will get the start time of y of n, right? So how it will be identified? So similarly or you can say it as the what, start time of x of n plus start time of y of n, right? Start time of x of n and plus start time of h of n, okay, will be the start time of y of n, or you can also say it as lower limit of x of n plus lower limit of h of n. So what is the lower limit of x of n? So it is starting with 0. Okay, 0, 1, 2, 3. So it starts at n is equals to 0 and it ends at n is equals to 3. Similarly, this h of n starts at n is equals to minus 1. Origin sample is 2. Okay, 1, 2. So it starts at n is equals to 1 and ends at n is equals to 2, right? So the start time of x of n is 0, okay, while the start time of h of n is minus 1. Okay, so 0 plus minus 1, so it will be minus 1, right? So your phi of n, okay, will start at n is equals to minus 1. Okay, so after the minus 1, 0 time unit will be there, then 1, then 2, then 3, then 4 and 5. Okay, so it will start at n is equals to minus 1 and it will end at n is equals to 5. So total 7 samples will be there. If we count these values, so 1, 2, 3, 4, 5, 6, 7. Okay, so total 7 samples will be there as well as identified here. Right? Total 7 samples will be there, but your sample values will start at minus 1 and it will end at 5. Right? So these will be the values of n for identifying y of n by using convolution summation. Right? So we'll try to solve this problem by using tabular method as well as matrix method. Okay, so in tabular method, as here you can draw one table, okay, where you will specify the values of k. Okay, so k will be varying from some limits. So again, x of k you will be writing, then you will write h of k, then you will write h of minus k, that is folded version of h of k. Okay, and to identify the values y of n, okay, in this given convolution summation formula, as n is varying from minus 1 to 5. Okay, so you will need, when you are substituting n is equals to minus 1 here, so it will be h of minus 1 minus k. When you will be substituting n is equals to 0, so it will be h of minus k, right? When you will be substituting n is equals to 1, so it will be h of 1 minus k. Similarly, 2 minus k, 3 minus k, 4 minus k and 5 minus k. Okay, so you will be substituting values of n starting from minus 1 to 5, right? So n will be replaced with minus 1 to 5. So according to that, here you will need h of minus k. When you are substituting n is equals to 0, you will need h of minus 1 minus k when n is equals to minus 1, right? Similarly, there will be h of 1 minus k, right? H of 2 minus k, h of 3 minus k, h of 4 minus k and h of 5 minus k, right? So here you can simply specify the values of k. Just for example, you can increase these values. Okay, if you identify in the given sequence, okay, the minimum value, because you will be considering this h of n as h of k and x of n as x of k, right? So in both cases you can identify the minimum value of k is minus 1, okay, and maximum value is 3, right? So here you can specify it as minus 1, 0. Okay, these values are for time, okay, discrete time interval. So minus 1, 0, 1, 2, 3, likewise. Okay, then you will specify the values of this x of k and h of k. So x of k is 1, 2, 1 by 2, 1. Okay, so x of k is at 0 it is 1. Okay, at origin it is 1. Okay, then at 1 it is 2, then 1 by 2 and then 1. Okay, then 2, 1 by 2 and 1. Okay, at minus 1 no value is there, that means it is 0, right, in x of k. Similarly, h of k is starting from minus 1, so it is 1, 2, 1, minus 1. So h of k is starting from minus 1, so 1, 2 1 minus 1. Okay, ends at 2, right? Ends at k is equals to 2. Okay, so these are the values for h of k, that is 1 2 1 minus 1, 1 2 1 minus 1, that we have written, right? Next, you have to obtain h of minus k. Now when you are substituting n is equals to 0 here, so you will get h of minus k, right? How it will be obtained? So simply you will be folding this h of k about origin. Okay, so in h of k at origin 2 sample is there, so this 2 will be as it is, right? 2 will be as it is. Okay, then you will be obtaining the folded version of it. Okay, 2 will be kept as it is. The values which are present at 1 and 2 will be at minus 1 and minus 2. Okay, so the value will be at minus 1 will be 1, because in h of k at 1 it is 1, so at minus 1 it will be 1, and at minus 2 it will be minus 1. So here we are not written minus 2, so I will specify minus 2 here, and below that I will specify value minus 1. Okay, which was at 2 initially in h of k, and the value which is present at minus 1, which is 1 here, it will be now at 1. Okay, so this value we have shifted here, right? And these two values, right, were shifted here. Okay, so no need to indicate these arrows here, right? But simply for your understanding, at about origin the value is same 2. The values which are present at 1 and 2 are now at minus 1 and minus 2, so minus 1 and minus 2, and the value which is present at minus 1, it is now at 1. Okay, so this is h of minus k. We were saying in the previous session, to obtain h of minus 1 minus k, you are simply shifting these values to left. Okay, if this n is negative. Okay, and if n is positive, then you will be shifting it to right. So if you are shifting it to left, then again this will be shifted by one position to left. Okay, so this will go to minus 3, right? So this minus 1 will go to minus 3, correct? Then this 1 will be at minus 2, this 2 will be at minus 1, and this 1 will be at 0. Okay, so this will be your h of minus 1 minus k, right? Similarly, you can obtain h of 1 minus k simply by shifting these values of h of minus k to right by one sample. Okay, so it will be simply h of 1 minus k will be simply, instead of starting it of minus 2, it will start from minus 1, so it will be minus 1 1 2 1, right? So sequence values will be same, minus 1 1 2 1, only simply by starting at minus 2 you are started it at minus 1. It ends at 2, initially it was ending at 1. Okay, one time in it. Similarly 2 minus k, so you will be shifting it again by one sample, so it will be minus 1 1 2 1. Okay, so you should specify this value below these proper columns. Okay, next, to obtain 3 minus k, again it will be shifted by 1, so it will be minus 1 2, sorry, minus 1 1 2 and 1. Okay, so here this one will be at minus 4. Okay, so it will start from time unit 1. Okay, k is equals to 1 and ends at 4, right? Similarly for 4 minus k, again you can specify it as minus 1 1 2 1. Okay, so it will end at 5, right? Similarly for 5 minus k, again minus 1 1 2 1. Okay, so it will end at 6. So likewise you can obtain this table. Okay, so after this you have to compute the values for y of n. Okay, for n is equals to minus 1 to 5, right? So what you will do, you will substitute these different values of n in y of n. Okay, so what was the formula for y of n? So simply y of n was summation k is equals to minus infinity, convolution formula, k is equals to minus infinity to infinity x of k into h of n minus k. So for n is equals to minus 1, you will get y of minus 1 is equals to summation k is equals to minus infinity to infinity x of k into h of minus 1 minus k. Okay, here you need to multiply these two values, x of k and h of minus 1 minus k. So these values you can observe here in the table. So this is x of k, right, and this one is h of minus 1 minus k. So these two values you need to multiply, but at minus 3 there is no value in x of k, so it will be 0. Multiplication will be 0. At minus 2 again there is no value in x of k, so it will be 0. At minus 2 again no value is there, so again it will be 0. At 0 value 1 is there. Okay, so this multiplication will be 1, right? Similarly at 1, 2 is here, but there is no value in h of minus 1 minus k, so 0 will be there onwards, right? So only 1 will be there in multiplication result. Okay, so y of minus 1 will be 1. Okay, so y of minus 1 will be 1. Similarly for n is equals to 0, because n is varying from minus 1 to 5, so next value will be n is equals to 0. So we will be identified as summation y of 0 is equals to summation k minus infinity to infinity x of k into h of minus k. Okay, because you are substituting n is equals to 0 in this case, so it will be h of minus k. So you will be again multiplying x of k and h of minus k. So x of k and h of minus k. So again at minus 2 no value in x of k, so minus 1 multiplied by 0 will be 0, 1 multiplied by 0 will be 0, right? Then 2 multiplied by 1 will be 2, and again 2 multiplied by 1 will be 2. So 2 plus 2 will be there, right? 2 plus 2. Okay, so it will be simply 4, correct? So y of 0 will be 4. Similarly for n is equals to 1, again you will write y of 1 is equals to summation k is equals to minus infinity to infinity x of k into h of 1 minus k. Okay, so again we will be multiplying this x of k with h of 1 minus k. Okay, so again here it is minus 1, here no value means 0, right? Then 1 multiplied by 1 will be 1, right? So we'll be writing 1 here, 1 multiplied with 1. Then here it is 2, 2 multiplied by 2 will be 4, right? So plus 4 will be there, right? Plus again in h of 1 minus k last value is 1, here 1 by 2, so multiplication will be 1 by 2. Next value is simple, no value means 0 will be there, so again there will not be any value. Okay, 0 will be there, but here we will write 1 multiplied by 1 by 2, so that is nothing but 1 by 2. So it will be simply 5 by 2, it will be 5.5 basically, right? Simply I can write, because 1 by 2 I can take it as 0.5, so it will be 1 plus 4 plus 0.5, so it will be 5.5 for y of 1. Okay, similarly for n is equals to 2, again formula will be y of 2 summation k is equals to minus infinity to infinity x of k into h of 2 minus k. Okay, I substitute n is equals to 2 here, right? So it will be 2 minus k, so x of k, I will be multiplying again x of k with h of 2 minus k. So again I can observe here both sequences are starting with 0 and ending at 3. Okay, so all values will get multiplied. So first will be minus 1 multiplied by 1 will be minus 1. Okay, so minus 1. Next plus, as we are doing summation here, okay, of these multiplication result. So first multiplication result is minus, then we are adding into it uh, this minus 1 after this 2 multiplied by 1 will be 2, right? So 2 multiplied by 1 will be 2 plus, so next value you can observe here is 2, so 2 multiplied by 1 by 2. Okay. So 2 multiplied by 1 by 2 will be 1 plus the last value. Okay, so last value here is 1, it is again 1 in x of k, so 1 multiplied by 1 will be 1, so 1. Okay, so the addition of it will be 5. Okay, so I of 2 will be 5. Okay, so that is in case of your y of 2, right? Sorry, here it is minus 1 is there. Okay, so minus 1 plus 2 plus 1 plus 1. Okay, so that will be 3 basically. We are not adding all these values, so it will be 3. So 2 minus 1 minus 2 minus 1 will be 1, 1 plus 1 plus 1, that will be 3. Okay, so that will be y of 2. Similarly, you will be identifying y of 3 when you will be substituting n is equals to 3 in this formula. So formula will be y of 3 is equals to summation k is equals to minus infinity to infinity, so x of k into h of 3 minus k. Okay, again you will be multiplying x of k and h of 3 minus k, so h of 3 minus k is here, right? So minus 1 will get multiplied with 2, so it will be minus 2, right? So minus 2 plus, so minus 1 multiplied by 2 will be minus 2, then 1 multiplied by 1 by 2 will be 1 by 2, so 1 by 2 plus, then 2 multiplied by 1 will be 2, right? Here there is no value, so 1 multiplied by 0 will be 0, right? So these will be the values. So plus 2 minus 2 will get cancelled. Okay, that will be 0 and 1 by 2. So here it will be simply equals to what? 0.5. Okay, 1 by 2 is nothing but 0.5. So your y of 3 is 0.5. Similarly, you can identify for n is equals to 4. So y of 4 is equals to summation k is equals to minus infinity to infinity x of k into h of 4 minus k. Okay, so again you will be multiplying x of k and h of 4 minus k. So here it is h of 4 minus k. So minus 1 multiplied with 1 by 2. So minus 1 by 2 will be there. Right? So minus 1 by 2 plus again 1 is there. So 1 multiplied with 1 will be 1. Right? It is 1 plus, so again h of 4 minus k, here it is 2, but here no value means 0, again 1, no value means 0, right? So 0 will be there simply, so it will be minus 1 by 2 plus 1, so it will be simply 0.5. 1 minus 0.5 will be 0.5, right? That is y of 4, right? Similarly, you can identify it for n is equals to 5, that is the last value of n. So y of 5 will be again summation k is equals to minus infinity to infinity x of k into h of 5 minus k. You will be identifying, right? So how it will be identified again? So we will be multiplying this h of 5 minus k with x of k. So here only one value is there. Okay, that is minus 1 multiplied by 1 will be there. Okay, so minus 1 multiplied by 1. So it will be simply minus 1. The remaining values you can observe here. So at 4 1 is there, but at 4 no value is there. That will be 0, 2 multiplied by 0, 1 multiplied by 0. So only minus 1 multiplied with 1 will be there. Similarly, 1 by 2, here no value, that means 0, 2 multiplied with no value 0, right? 1 multiplied with no 0. so only -1 will be there at y of -1. So the response of given DT-LTI system is, so you'll be simply writing these values. Okay, so you get at n is equals to -1 value 1, right? Then at origin, that is at n is equals to 0, value is 4, then 5.5, okay, 4, then 5.5, after this at 2, 3, then 0.5, then 3 is there, right? This 3 is there, y of 2, then 0.5 there, right? So 0.5, 0.5, and last value is -1. Okay. So this will be the required response of the system. Okay. So 1, 4, 5.5, then 3, 0.5, 0.5, -1. Okay, this is how we identified it by using tabular method. Okay, we obtained table initially, and from that table we got the multiplication and summation result at various values of n. Okay, now we'll try to solve this same example by using matrix method. Okay, so here we'll see matrix method. Okay, initially we have seen the tabular method. Okay, this one is here tabular method. Okay, we have seen this tabular method. We'll try to solve now it by using matrix method. Okay, so as per matrix method, so this matrix method is simply used for the verification of result. Okay, so you have provided with the x of n and h of n in the given example, h of n 1, 2, 1, -1. Okay, so it is 1, 2, 1, -1, and x of n is 1, 2, 1 by 2, 1. Okay, here in h of n, origin at 2. Okay, 1, 1, 2, 1 by 2, 1. Okay, so it is 1, 2, 1 by 2, 1 is your x of n. Origin is at first 1, but in h of n it is at 2. Okay, so how matrix method is performed? Okay. So simply we will obtain a matrix here, right, where you will be plotting the values of h of n and x of n simply. Okay, so these will be simply written here as what are the values of h of n. So it is 1, 2, 1, -1. Okay, and the values of x of n is 1, 2, I'll write instead of 1 by 2, I'll write here 0.5 and 1. Okay, and then I will simply multiply these values. Okay, so 1 multiplied by 1 will be 1, 1 multiplied by 2 will be 2, 1 multiplied by 1 will be 1, then again 1 multiplied by -1 will be -1. Okay, again 2 multiplied by 1 will be 2, then 4, then again 2, again -2. Similarly 0.5, okay, 0.5, then here it will be 2 multiplied by 0.5 will be 1, right? Then again 0.5, okay, then 0.5 multiplied by -1, so it will be -0.5. Similarly 1 multiplied by 1, 2, 1, -1. So this is the required matrix. Okay, so after obtaining this matrix you will separate these elements diagonally. Okay, so how? So this will be separated, right? Then next this will be separated out, then next this will be separated. Okay, here it is 1 basically. Okay, similarly So like these values will be separated. Okay, so in matrix again you will identify, simply you can write down directly y of n as you will sum these values, okay, which are present in each one of this section. Okay, in first section only one is there, so this one you can write it as it is because only one value is there. Here two values are there, that is 2 and 2, so you will sum these values, so 2 plus 2 will be 4. Okay, then you will be summing this value, that is 0.5 plus 4 plus 1, so it will be 5.5, right? Then you will be adding these values, 1 plus 1 plus 2, that is 4 minus 1 will be 3, right? Then again you will be adding these values, 2 plus 0.5 minus 2, so it will be 0.5, right? Similarly 1 minus 0.5 will be 0.5, and last one is minus 1. Okay, so last value is minus 1. Okay. So this is how you are obtaining it as matrix. Okay, and origin it as at 4. Okay, this is how we are identifying the origin, because n is starting from -1 and ending at 5. So this will be at -1, this will be at 0, this will be at 1, 2, 3, 4, 5. Okay, at n values. Okay, so this is nothing but the matrix method. Okay, and this matrix method is only used for the verification of result. If in examination, if you have been asked to identify the convolution or to identify the response of the system, so you can use graphical method or tabular method. Okay, if it is explicitly specified to use the tabular or graphical method, so you have to use the specific method. If it has been asked to use the tabular method, identify the convolution by using tabular method, so you will be using this tabular method. Okay, if it has been asked to identify the convolution by using graphical method, then in previous session we are seeing the graphical method. Okay, if method is not specified, then and question is asked for 7 marks, then you can use graphical or tabular or mathematical method. Okay, and if it is asked for 2 marks, then you can use matrix method, right, to identify the response of system by using convolution, right? So in today's session we'll discuss tabular method and matrix method for identification of response of system by using convolution summation, right? In next session we'll be discussing the mathematical method. So which is simply by using the formula you can identify the convolution by substituting various values of n and k in the given convolution formula, right? So out of these four methods, you can use any method for identifying response of system, and for examination purpose, depending on how much marks are there, you can use the selected method. And you should not confuse with the matrix method and tabular method. Matrix method is separate one, tabular is the method that we are seeing in the today's section. Okay, so we have seen both methods, that is tabular as well as matrix, but in most of the books that matrix method is given as the tabular method, but matrix method is not a tabular method. Matrix method is different one and tabular method is different one. Okay, so thank you for joining this session.